In this video, what we're going to do is we are going to look at cost and sine graphs and how they can be transformed. Now here I've drawn a standard cost graph. It starts at 1, comes down to 0, height at 90 degrees, minus 1 at 180, back to 0 at 270, and up to 1 at 360 degrees. So we've got this a standard cost curve. And we're going to talk about how we can transform it. Now we can put a number at the front. So at the moment that number is 1, but we can change that number. We can put a number in front of the x, or we can add a number on the end. Those are the three places we're going to think about. So let's first start by changing that number out the front. Let's make that number bigger. So as we make that number bigger, we see our graph is getting stretched in the y direction. And even if we go for, say, 0.5, we see that our graph is just half as high as it was before. Now, if you do physics, you might think of this as the amplitude of a wave. But equally, just thinking of it being stretched and squashed is absolutely fine at the moment in terms of maths. So that gives us our first transformation. Oh, sorry. Give us a second. We'll bring that on. So, first transformation is if we have a being a positive number, then it stretches our graph in y by however much that number is. What happens if a starts to go negative though? Here we go. Well, look, if we make a minus 1, our graph now starts at minus 1, goes to 0 and goes up to plus 1. So we've actually flipped our graph over in the x-axis. So making a negative flips our graph over in the x-axis, and if we then make it minus 2, we can see it flips it and it stretches it. So it flips it. So instead of starting at 1, it started at minus 1, but we've done minus 2, so it also stretched that down to minus 2. Now, let's play around with b. So I'm going to reset a back to 1. And let's play with b. So this is changing the number in front of the x. As we increase that number in front of the x, we can see that we're getting, our wiggles are happening more and more frequently. Now that might seem a little bit counterintuitive, but we're going to come up with a quick and easy way to remember that in a minute. But just for the moment, let's record that. If b is greater than 1, we're kind of squashing in the x direction. What happens if we make b small? Well, we can see that our graph is getting stretched out. So if we go 0.5, it's actually taking all the way to 360 to get halfway through our curve. So b being less than 1 is like a stretch in the x direction. But as I said, there's a handy way to remember this, and here it is. The way that I always like to think of it, drag the graph. The way that I always like to think of this is it's really telling us about how many waves happen every 360 degrees. So when b is 1, we get exactly 1 full cos wave. When b was 2, we can see that we do a whoa down and up by 180, and then another down and up by 360. So when b is 2, we get exactly 2 waves in 360 degrees. Let's reset for our final one. Okay, so this time we're adding something on the end. So let's do that. Well, we can see as I make c bigger and bigger and bigger, positive, our graph moves up. And if we make c negative, there's 0, so our graph is its normal. If we make c negative, our graph moves down. So we can see that this value that we're adding and subtracting on the end either moves our graph up in the y direction, or if it's negative, it moves our graph down in the y direction. So we can do these operations to move our graph around, and we can describe it using our equation, and that's a really valuable little thing to be able to do. Of course, you can combine these, so we could do a stretch by 2 in the y direction, and we could move it up by 1. So there we go. There's the graph of y equals 2 cos x plus 1, because we've stretched it by 2 and we've moved it up by 1. We could do, let's reset to our standard graph. Equally, we could increase the number of waves happening, so we could maybe even go 3, so y equals cos 3x, but then we could move it down. So we could have like minus 2. So that's the graph of y equals cos 3x, because we've got 3 waves happening in 360 degrees. But where's the middle of that wave moved down to? Well, the middle is moved down to minus 2. So that's like having a minus 2 on the end of our equation. So combining these can lead to all sorts of graph transformations. Now I'm going to do a separate video where I actually do some examples of sketching a graph using these transformations, but that shows you, using this little tool, we can see all those different things happening and we can get a feel for how they look on the graph. And you can play around with this, you can have a go with this yourself.